Well, thank you very much for inviting me. It's really a pleasure to be here. And it's amazing the kind of technologies we have nowadays. So I am the director of the CITIUS. CITIUS is the Research Center in Intelligent Technologies of the University of Santiago de Compostela. And the organizers have asked me to introduce you briefly this research center. So I am going to do that. I'm going to talk about briefly too, but to talk about some of our research lines which are not nowadays applying the center at least to neuroscience or neurotechnologies, but potentially at least it could be applied. So my idea is to try to inspire you some ideas, and particularly the idea is about to collaborate with us in some sense. So, well, sorry about the infographic. I am going to summarize it because the print is really small. But we are more or less 130 people, 130 researchers. 35 of us are senior researchers, and 70 are PhD students from more than 10 different countries. Our research is focused on 9 areas organized in 4 main fields, which are green and smart computing and devices, but mainly electronic design and high-performance computing applied to artificial intelligence, support for machine learning, particularly machine learning and automatic reasoning, intelligent technologies, and trustworthy AI. We are nowadays involved in 9 European projects, but I'm going just to mention 4 of them because we are the coordinators of these 4 projects. One is an ERC Consolidator Grant project related with virtual reality. I'm going to talk just briefly about it. 3 are 3 European training networks that we coordinate. In fact, I am the coordinator of one of them, sorry, in the area of explainable AI using natural language processing. Another one is in the area of smart sensors. I'm going to talk about it too. And the third one is in the area of disinformation on the internet. During the last 3 years, more or less, we have been involved in more than 40 contracts with industry, from startups to global companies. We have started 4 spin-offs in the last 10 years. In fact, I am the promoter of 2 of them. One is Senén Technologies, which has a leading technology for positioning, guiding, and tracking people and assets indoor. And for example, in the T4 terminal of the Madrid airport, the geopositioning services are all of them based on Senén's technology. And the other one is in Verbis, which is related with a field of AI, which is called process mining. And finally, regarding this infographic, we have organized the CAI. The CAI is the European Conference on Artificial Intelligence. It's the most important scientific event in Europe related with artificial intelligence, and one of the most important all over the world. Unfortunately, it was in 2020, so due to the COVID, it was fully online. But the European Association of Artificial Intelligence have asked us to organize it again, and I don't know if it's a good decision, but we accept it, and we will organize again in 2024 in October. So it will be a good occasion for all of you to visit Santiago and to visit our center. So we really proud to welcome you there. In fact, I know that neurotechnologies have their own scientific conference, specific scientific conferences. But anyway, in more general AI-based conferences, the number of papers related with neuroscience and particularly neurotechnologies is increasing a lot. So I'm sure that in ECAI 2024, there will be a bunch of papers related to this topic. I would like that, in fact. So let me just talk about three research lines in my center, which, from my point of view, are potentially, at least, applicable to neurotechnologies. This is the first one. Is related with electronic design of intelligent devices. And the picture of your right shows a chip designed at Citius, which includes a 1 square millimeter microsolar cell. And what is important, what has been designed specifically for us, is the power management unit, which is even smaller, just 0.6 square millimeters, and is capable for working with input powers as low as 2.3 nanowatts. We can put 350 of these power management unit in just 1 cent coin. This chip, in fact, has the best performance achieved so far in terms of autonomy and compactness, and it is able to provide energy to maintain, for example, Bluetooth, low-energy communications, even with light powers of just 500 nanowatts. So we have been testing this chip with the idea of applying it to intraocular pressure monitoring related with glaucoma. Probably most of you know that this is one of the main causes of blindness. And what I would like to say is that in this particular case, we use a microsolar cell in order to provide the electric current power to other chips, for example, for sensing or communicating information. But it is possible to substitute this energy source by any other source of energy, just changing the electric current transducer. So it could be used, for example, in order to obtain energy from head, from the body. So we could use this kind of chips in order to implant them in the body, or particularly in the brain. We are part of another ambitious European project called MISSEL, which aims to bring artificial intelligence to edge computing using bio-inspired low-power autonomous vision system. In this particular case, the system will be able to obtain and process multispectral images in the visible and near-infrared regions using an array of graphene photodiodes. So this will optimize, as in the previous case, parameters such as size, weight, and power consumption on the chip, having potentially, again, implantable devices even in the brain. In our intangible realities laboratory, there are several researchers involved in how multi-person VR can be used for scientific simulation, visualization, and education. And one of the most recent, and from my point of view, interesting results show that VR can produce perceptual effects which are comparable to psychedelic drugs, obviously without their associated risks. In fact, these results have been published in very high-impact scientific journals, but at the same time, they have been widely reported in technology magazines and even in the media, because it's really a very interesting topic. And particularly, probably some of you know that recently the United States Food and Drug Administration has identified psychedelic drugs as a breakthrough therapy for treating anxiety, depression, and addiction. So there are a big number of clinical researchers that are quite interested on this kind of technology. And the last research line that I'm going to talk about is, because I think it could be very interesting also to apply to this kind of technologies you have been talking about this morning and probably tomorrow, is federated learning. Well, as you know, the easiest way to develop a model in order to solve a task using machine learning techniques is to have all the data together, and at the same time. So you can train a huge model in order to learn almost everything. But most, or at least a big part of the real applications, it is not possible to have all the data together due to data privacy reasons, or because the data are not all together at the same time. So the data is coming, and there are a lot of devices obtaining them. So the idea of federated learning, which has been proposed recently in 2016 by Google, is not to share the data. The data is just in the devices that obtain this data, but to share the model. So each device, a smartphone or an IoT device, obtain the data, train their local model, share the local models in order to obtain a global model with a performance higher than each one of the local models. So the global model can solve the task better than each one of the local models. So in this case, we share, I insist, the models, but not the data. And we are heavily involved in this research line with very good results. For example, we have applied to know the physical activity detection using smartphones. Smartphones and in general, devices are very cheap. It's available for almost everybody. So you don't need, for many applications, you don't need specific technologies just to use what you have in your hands or in your life every day. In fact, it is not the research from my research center, but it is possible nowadays to diagnose the early stages of Alzheimer's disease from movement patterns during our daily lives using this kind of devices, or to diagnose Parkinson's disease from typing patterns on the keyboards of personal devices when the disease begins to appear. So the idea is, and this is one of my proposals, to use, of course, artificial intelligence and neurotechnologies during this day, and it will be tomorrow too. There are a lot of expressions you have used related with artificial intelligence signal processing, machine learning, and so on and so on. So neurotechnologies and artificial intelligence will be together. And in many cases, it is possible to use this kind of devices, such as smartphones or any wearables, for example, in order to attain and to solve many real and important problems. And that's all. Thank you very much.